I'll put my thing out there. 21.
All right, give me questions. 33 and 30.
Hey, Julio. What?
Did you call him Coolio? All right. All right, here we go.
He was eating.
Look at this. All right. This is. Somebody said 13. Who got my green sheet?
I know you did not just put food on the ground. I was like, she's one that like punches the nurses. Like she's insane.
Y'all better be
I
careful.
was like, that's what we're supposed to do. Get it up. And then we did it again. She gets up and she gets her walker.
All right.
And then she just stopped and like stared at me.
This is Kenzie. 3. All right. So, right, I'm using, y'all said you didn't see the thing here, but it's the bottom right next to the last one, a to the x. If the base is a constant, that's what you use. Wyatt, what you got? No, so I will delete the side where it says what it equals, and that's what you'll fill out.
Wait, is this the same?
Maybe. Might be mixed up.
Stop. Stop being so annoying.
So you're gonna leave like half of it and we fill in the rest?
Yeah.
I wanna know how the camera like.
Yes. So for 18 plus 4, 22. 22 question. All right, we got to chain it, right?
Whoa. Whoa. Wait a minute.
I did it in parentheses like this because I didn't want you to think I was subtracting it here. It's multiplied by a negative. So really, this is just a negative 3 cosecant x log x cosecant x cotangent x. Or if you wanted that in the beginning, if that was anything other than x, I would need another chain, right? If that was like 2x, what 3?
A log 3.
Alright, so what's going to include, you don't have to remember the natural logs, right?
No, you did.
The whole thing? You gotta remember just the back part, right? Yes, the back. Well, why would we have to remember? Not that stuff. I know, but why would we have to remember? Right?
No, that's kind of implied there. I mean, if you wanted to do this, you could, but. All right. What else from your homework? 17. Hot July moon. All right. So the derivative of natural log is, of course, 1 over whatever that x is, and then I chain it, right? I'm gonna change this, yes, so that you can see. Now I'm gonna multiply by the chain of x to the negative 1, which is negative x to the negative 2. We'll take this slowly, step by step for you. 1 over x is just x, right? Times, I'm going to throw the negative out front so it doesn't start confusing me. Negative 2. I've got the same base. What do I do with the exponents? Just add. Are y'all typing ugly stuff on that calculator? All right, what else? What? All right. This is a double chain. This is a double chain. 1 over the log of x. All right, listen. 1 over the log of x, because that is the derivative of this. I do 1 over the argument times, and now I chain it, so I do the derivative of this. So the derivative is 1 over x log x.
So, bro.
Because just, yeah, derivative of just log x is 1 over x. Yeah. Would y'all focus?
Can we get a class for Adderall?
Yes, 25. And 21. 21, y equals log base 4 of x squared. So now I'm going back to this sheet, right? And I'm looking at the one that is very bottom right. Log base a of x. A is your little base number, x is your argument. Okay, so I'm going to do 1 over x squared times 1 over the natural log of 4, but now I have to change times 2x. Now, this becomes, this is in the top, right? 2x over x squared log 4. So I get 2 over x log 4. Not necessarily. They did what? What number is this? They did 1 over x log 2. I'm not. I could show. Y'all don't want me to show you why? You can do that. Bet. You agree with that? 4 is not 2 squared. But log property. They were asking, they said that you couldn't simplify that anymore, and I said, actually, you could if you did that. No, I did a log property. No, we did them first in Algebra 2, and then we did them again in Pre-Cal. Remember? Yes, we did. Yes, we did. This is expanding. This was condensing. That was one property. Another one was, I'm not a fan. That couldn't be the only one in the whole family. The kids have had one forever. Right. Russell and I had Angel. There's not. I was mad last night. I said, hey, just crap back. You've never had an Android? How do you know? Oh, I can't wait. All right. What?
Like 11:30 at night.
What else?
Wait, that would be fun on your learning.
Huh? 27? 27. All right. Oh, I'm sorry. 25. All right. Log base 2 is a constant. Okay, so treat it as such. There's no variable in there, so it never changes, so I treat it as a constant. Which means, remember, whenever I do a derivative, the leading coefficient, if it's a constant, can come out. So I'm really doing the derivative of, I'm doing log 2 times the derivative of log base 2 of x. Right? This would be log 2 times the derivative of log base 2 of x, because you can pull that constant out. Times, if you did product rule here, derivative of the first is 0. So you could do product rule if you wanted to, but it's not necessary. All right, look, log 2 times. What is the derivative of log base 2 of x? 1 over x times now what happens?
So,
I do just have an answer. That's been a property since the very, very beginning. Look back at your derivative rules. What else from your, oh, 27. All right. Derivative here. 1 over the argument, right? Times 1 over the natural log of the base, but then I have to chain e to the x, right? No.
33 to 35.
Yes, Kaylin. It ends up being a constant, which is kind of cool. All right, 33, then 37. Shh, 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 shh. Stay with me, Logan Freeman. I thought you were in the hallway. Pi is a constant. Again, it's not, I mean, it's a variable, but it's a variable that represents a constant. So we treat it as a constant. So I just do power rule. Pi times x, and then I subtract 1. That's it. That's all. Then you said 37. Oh, great day, y'all. So we've done same thing. Don't feel like that. Why can't I? This must be an iPhone thing. It's not working right. It's that dang iPhone. Who said? Somebody said go back. Somebody said go back, go back, go back. All right, same thing. This is the exact same thing. Square root of 2. Square root of 2 is a constant. I'm just going to do power rule. Multiply in front. Subtract 1. That's it. That is it. Yes. It would still be a constant. It has to have an x to not be a constant. Did y'all hear that question? Because that might help you. In determining if it's a constant or not, if it has an x, it's not a constant. If it doesn't have an x, it's a constant. So there's no x on that, it's a constant, right? The other one was like log 2 times log base 2 of x, constant because there's no x in it. Yes? Yeah, well, kind of. 37? Don't worry about domain. Don't worry about domain. All right, so find the derivative. 1 over the argument and then chain it. This doesn't have a chain, so I stop.
41.
41.
Yeah.
All right, so derivative of a log, 1 over argument times natural log of the base. Now chain it. Oh, sorry. Times 3. Okay. Y'all cook? Yep. What else? No. That was probably the last one y'all had to do, wasn't it?
5-minute brain break.
No, you've been on a brain break this whole time.
No, I haven't. I've been logged in. I've focused the whole time.
I'm throwing it around right now.
Hey, anybody get
Where
a
you
fight
go,
video of those two girls?
The amount of radioactive plutonium. Have y'all ever seen that?
Hold on. Whoa. Wait, this isn't on our test. You said we're done with Unit 3 yesterday. What are we doing?
I'm telling you. Just now.
What are we doing?
Listen to my question. The amount of radioactive plutonium. Repeat what we do. Tell me again. All right, this is A of T, yes? If I want the rate that it is, what did I say? The rate that it's decaying, rate decaying when T equals 2. What is it that I'm looking for? Derivative, right? I'm looking for the derivative at 2. Rate means derivative, yes? All right, give me an equation for the derivative. This is same section.
1/2 T divided by 140 ln 1/2.
Whoa, 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 whoa. Give me an equation for the. You can't power rule this one.
Oh, I just read.
All right, right. Which one are you using? A to the x. Notice the base is a constant. The variable is in the exponent. That's the a to the x, okay? The 20 I'm going to leave alone outside. Yes? And now I'm going to do the derivative of this. It's that constant coefficient. All right, so now I'm going to do, I'm going to do a to the x. So 1/2 to the t over 140 times natural log of 1/2, but now I have to chain it. What is the chain of this? That's it. Now, what? What do you mean, what equation did I use? A to the x. Now, this is a calculator problem, so get out your calculator. I am not even going to worry about this since this is a calculator problem. Instead, I'm going to put this in y1, and how do I find a derivative at a point on my calculator? In deriv. Okay, so input this in y1 to show you that you could do it. You did. Where'd it go? I'll toss it. X, just use X, that's fine. Well, now I don't have a calculator. No skibbity over here. Do not learn from my third block. Max teaches me lots of stuff. Yeah. All right. I'm going to put it in y equals. Somebody has it. Okay. X, put a T in for X. So 20, 1/2 raised to the X over 140. When T equals 2, yeah. Depending on your calculator, you might do this slightly different. 140. Math. Yep, in deriv, I'm going bars, comma X, comma, where did I say? 2.
Big number.
Shouldn't be a big number. It should be like 0.098. Negative. And why is it negative? What did we say from the beginning? What? Oh.
I already hit it.
So don't do deriv into y equals. Do. It's so bright.
What is that small one on?
You don't put it in white.
All right. Math. Delete.
Oh, mine deleted the whole thing.
All right. I'm in y equals. There's your equation. Type in. Y'all, a lot of y'all missed this on your test, but it was just being able to plug it in the calculator. So I do want to make sure everybody can do this. All right. Second quit. Math. Go down to number 8. Enter. So this is your d dx. I'm going to put an x there. This is where I'm going to put the function, where I type the function. So this is where I go vars. Right here below the. Over to y vars. Enter. Enter. No, you need to be able to do this. Yours is like mine. Let me put mine back up there. Give me a second. And hit enter. It said when t equals 2 days. By the way, if you like to follow along, I'm on page 194 in your book. It's number 59. It's a word problem. 59. If yours is in y equals, here's what it looks like on this one. All right, you're in y equals, you typed it in. Hit second mode for quit. Now math 8. All right, so bars right here. Over, enter, enter. That says take the derivative of y1. I did bars and then I went over 1 to function, hit enter, and then chose y1. Then do a comma, and you have to tell it the variable that you're taking the derivative with respect to. So that's always your x. Then comma, now the value at which I'm doing it, which is 2. Uh-oh. Now, why is it negative? Listen to the problem again. The amount A in grams of radioactive plutonium remaining in a 20-gram sample after T days is given by the formula blah. At what rate is the plutonium decaying when T equals 2 days? It's decaying, so it's decreasing at negative 0.098 what? Grams per day. Per day. Where are you at in y equals? It goes here, like I did exactly. Why do you have a log in here? No, this doesn't go.
That's what it keeps doing. Let me show you.
All right, hold on. You gotta come out of here first.
Here, wait. Let me just. Where's the problem?
20. 1/2.
You do it like really good.
Raise 3. 140. Close parentheses. Now do second mode. Now math. Go down to 8. No, this is x.
Hey, yeah,
Y1.
get up if you just go to it here and yell, get out.
It's like enter? Okay, well, now.
Yeah. All right. You like those? That's 150. That's 150. The flu, it's almost flu season. The flu is spreading at the rate of blah. All you healthcare people. This is actually a non-calculator. All right, listen. Listen to the question. You have to be able to interpret the question correctly. So listen. The flu is spreading at the rate of P of T. What do I have? Okay, I got the speed that is spreading. Speed or rate is another word for what? Okay, another word for somebody. It's a derivative, right? So I've already got the derivative here is what I'm getting at, okay? Is everybody okay there? Come to your seat, boys. This is why y'all fuss whenever we don't have time for you to do your work in class. But y'all are the ones that waste the time. If I was in this class, I would be very upset with the boys who cause those issues. I would be fussing. But if they realize how frustrated y'all are with them, they will stop because right now they want attention. If flu is spreading at the rate of P of T, what is the initial number of persons infected?
Oh, how do I put it in?
Okay.
How do I put it in?
There's that button for E. I want y'all to be thinking about it. See what you come up with. How many people were first infected? What was the initial, how did it start? How many people were initially infected? Is it? See what you get. This is what's gray mean? Gray is non-calc. I always get confused. Gray is calculator. You sure? Okay. Okay. Yeah, that's right. That's right. That's right. Okay, so this is calculator. Not calculator. No. 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 It's a gray problem. With a gray background indicate problems that have been designed to be solved without a calculator. All right. Okay, a little over 2.5 people, right? So if my choices were 1, 3, 7, or 75, what are we going with? 3. Tell us what you did, Slade. Okay, he plugged it in, but what did you plug in? If it's a non-calculator problem, what can we do? If you plugged in 0 for t, you got 150 over 1 plus e to the 4th. That's definitely a calculator problem. Yeah, that's definitely a calculator problem. Moving along. Let me ask y'all this, because this was my plan for today. Thank you, Solomon. Logarithmic differentiation is a technique we use sometimes in calculus to find derivatives that are very difficult to find. However, you can always use the rules here to find those derivatives that may just be a little more complicated. But logarithmic differentiation requires you to remember all the properties of expanding and condensing logs that we did in pre-cal and algebra 2. Would you rather keep doing it the long way with the ones from the green sheet, or me to show you the logarithmic differentiation technique? Okay. That was what I was going with. No problem. I usually teach it, but y'all are struggling with the log part a little bit, so I was thinking about leaving it out. We didn't have to there because it was already given as the derivative. The point was you have to really read the question to see what they're asking. Ask me again, Logan, what'd you say? If we have some time at the end, we'll throw it in at the end and I'll show you. As we go. It's not necessary. Yeah, that's number 68. Which of the following gives the slope of the tangent line to the graph of y at x equals 2? So I want you to find the slope of the tan line. Slope of tan line. No calculator. Derivative. That's right. Do it. Mark, set, go. Mm-hmm.
Oh, I see that.
Leave it in the answer. If you don't have a calculator, leave that in there.
Don't play with chairs.
Are you okay? Did you have 4 on the floor? Did you have 4 on the floor? Were you leaning back in the chair? So how did that happen, Sonny? Slade, are you messing with him? Sit your butt down. All right. Did you get negative log 2 over 2 for your slope? If you didn't, you're wrong. If you did, you're right. If you didn't get that. Let me leave them. Yes, if they asked you for the equation of the tan line, that's a different problem, right? I've already got the slope. I'd also have to find the point, but I'd be using that original equation for the point. You leave it as what? Well, you could if it was open-ended. The choices, this was a multiple choice question, so the answers were formatted in -1/2, -2, 2, or negative log 2 over 2.
Whoa, that's the key. Why did I give you just a bunch of random ones?
Wait, so you use 2 different formulas in that?
You think? Yeah, but don't always assume that that's the way it is and that the one that looks like out of place is the answer, because it's not the way it is.
So you
Do it what?
use 2 different formulas?
No, I took the derivative and I plugged in 2 for the x.
And then you ended up with negative Ln.
I used
over
the
2, so you use this one. And then,
I used the a to the x equation.
yeah, and then in the second half of your,
I didn't take the derivative again. The derivative of a to the x is a to the x times natural log of the base. This is the change. Because 2, if I plug that 1 in, right, 1 minus 2, or the 2 in, 1 minus 2 is -1,
so you just want to.
and that makes it into a fraction, yeah. All right. Shh. Say that one more time. No, say it again. Yes. No. The point has nothing to do with the slope. If you were asked to find an equation, this is your slope. Slade, put it up. Your point is going to be back to the original equation and you're plugging in 2. Right. So it would be 2 to the 1 minus 2. Yes, Ellen, 1/2. 2 to the 9. So the point there would be 2 1/2. So you got y minus 1/2 equals the slope. Logan, hush. X minus 2.
I've got to work on my list.
No, just don't do it while I'm talking. Make sure you're numbering the problems as we go. That was 68, yeah. I'm kind of ping-ponging around.
Is there homework problem? Is there homework problem?
No.
What was that
26. Find the derivative. Find the derivative. Mark Sega. Is it? Yep, find the derivative. What? All right, did y'all get it? All right, so I'm using the log from my green sheet, yes? 1 over the argument times 1 over the log of the base. Now I have to change. Whoa. Yes, you're right. You're right. It's constant. You're right. Good job. Okay. I was fixing to do product rule, and then they're correct. LN3 does not have a variable in it. It's a constant times a variable. So if you had 3x, what's the derivative of 3x? 3. What's the derivative of 5x? 5. What's the derivative of log 3 of x? Log 3. This is different than this. Just basically, but yeah. So now this and this are gone because they cancel out. So the derivative is just 1 over 1 plus x log. I haven't set it up yet. I'm telling you, I'm not impressed.
You'll get it.
I just want my old phone back.
No, that's the double
You
thing.
download
Oh, I'm sorry. Good job, Wyatt. I want a point on the graph of y that is tangent to, tangent to the line that is perpendicular to this line. I want to make sure this is number 29. So if you want to read it the way it is in the book, let me read it exactly the way it is so you see. Because I want y'all, these are the kind of things y'all struggled with on the test. With, okay, I know what a tan line is. Okay, I know how, but I can't, whenever you ask me a question in a sentence, I can't apply it and put it all together. So listen very carefully. At what point on the graph of y equals, oh, I wrote that. This is 30, not 29. I think my brain went, I think it's a combination of 30. At what point on the graph of y equals 2e to the x minus 1 is the tangent line perpendicular to the line y equals negative 3x plus 2? All right, so at what point on this is the tan line perpendicular to this? 193. Yes. Yes. So I'm going to break this down to try to see what they're asking me, because that's where I'm going to be successful with the problem. First thing is, tan line, I know if I'm talking about slope of tan line, this is derivative, right? So I'm wanting to know, where is the derivative of this function equal to, well, what is the slope that's perpendicular to this line? Perpendicular lines have a negative reciprocal slope of one another. Huh? I know. So do it. Where does the derivative equal 1/3? And remember, this is a calculator problem. This is a calculator problem. So I want to take a minute too to show you how to solve this, because this is another area where we struggled on the test. After 68, which other one did we do? You can. You cannot have those. You have a list of recommendations. They're not requirements. That's at her discretion. The academic requirement, the academic recommendations are at the discretion of the teacher, and those are at the discretion. There's nothing that's required. All right, how would I solve this? So first thing I'm going to do, I'm going to find this derivative. Okay. So derivative is just 2e to the x. That's it, right? So my question is, where does 2e to the x equal 1/3?
Have to set it equal to 1/3.
So I'm going to show you how to use the calculator. This is an easy example. This is kind of like the one that we talked about, but it was like a secant and a something. But any equation that you have your calculator that you can use, you can do this one of two ways. You can use it this way, or you can set it equal to 0. I'll show you both ways to show you that either one. Let's focus on this one first. Take out your calculator. This is a good tip to have. All right, in the first y equals, I'm going to put this equation, 2e to the x. 2e to the x. Okay? In the next equation, I'm going to put 1/3. That's the wrong e then. Second ln down here under log. You see it? Huh? Yep. Now, if I want to know where these equal, what you looking for? I'm going to do a Zoom 6 since these are just basic fun. They're not a trig or anything like that. It's hard for you to see on here. I can zoom in just a little bit. I don't need to do this function. Okay. I did Zoom standard, Zoom 6. Just so you can kind of see what's going on here, I'm going to zoom in a little bit. I'm going to make my y's. I'm going to go from 0 to 1 so you can really see. Here's my 1/3 coming in, right? So if I want to know where these two equations, remember the two equations that are graphed, I just got to find the intersect. I got to find where they cross. So if you go second trace, if you look, option number 5 says intersect. This is why this is so easy. Once you get the equations in here, hit intersect, and then you don't even have to do left, right on intersect. You just first curve, enter. Second curve, enter. Guess, enter. What point do they intersect? -1.79 1/3. Okay, and if it says where, then all I need is the x value. I don't even need the whole thing. This one asked me for a point. What? Yes, yes. Second trace, intersect. If there are multiple points on your test, there were multiple points, all you have to do is kind of scroll over close to the intersection and hit enter 3 times. That's logarithmic differentiation. Yes. That's the x part. That's the x part. The x part's where they equal each other, right? So -1.79. Is that not what they have, is -1.79? Okay, so the y value, remember what I'm doing, it said at what point on the graph of this, so I need to plug that 1.79 whatever. Well, that's the y where these two lines intersect, but it's not going to be the point on that original graph. Yeah, because it usually just says where. Yeah. If it asks you for the y part, then you also have to do it. Now, the other thing you can do, some people would prefer to do this, is you can set it equal to, well, and this is an easy one to solve by hand, but it's also an easy one to illustrate how this works. You can also set the equation, instead of doing 2 different lines and finding the intersect, you can just set the equation equal to 0. I don't know what y'all prefer. It doesn't matter to me. Minus 1/3. Set the equation equal to 0. right? That's what equals 0 here. And then I'm just going to find where it crosses the x-axis, but then I do have to do the left-right bound. Which equation? That equals 0? I just subtracted the 1/3 over and made it equal 0. I plugged the right side of the equation in for y2. Oh, original equation. Second. You see we get the same x there. The 2e to the x minus 1. Depends on if it's calculator or non-calculator. If it is calculator, I would most definitely use my calculator to find that solution, and I would not, especially since it's such a nasty decimal. That's always going to give you the right answer as long as you input the equations correctly the first time. All right, what I want you to do before you leave. There are, it is 9, 10, yeah. Before you leave. Your homework tonight is to study for that quiz tomorrow. But before you leave, I want it handed to me. And with this, I want you to do it on the same page that you did your notes just now. And so I want included in this page numbers, what was it, 193 to 194. These are the ones we did together. Oh, okay. 59, 68, 26, 30, and then, yeah.
No, we didn't do it.
Yeah.